Hi students, I hope you all are doing well. In the last video we did the Adomian decomposition method for the Volterra integral equation of second kind. Right now we are going to do the Adomian decomposition method for the Fredholm integral equation. And I told you earlier as well, before doing all these solutions you have to watch a brief video on the classification of integral equations, like what is the Volterra integral equation and what is the Fredholm integral equation. So let's start an example to solve for the Adomian decomposition method. Fredholm integral equation is taken here, that is u of x is equals to sine of x minus x plus x times integral 0 to pi by 2 u of t dt. This is the Fredholm integral equation because both the upper limit and the lower limit are the constants. And this is the second kind Fredholm integral equation because the unknown function u is appearing under the integral sign and outside the integral sign as well. So this is Fredholm integral equation of second kind. To apply the Adomian decomposition method, we have to let here u of x equals to summation n is equals to 0 to infinity u1 n of x. You have to let it equals to equation number 1. Use it here as well and under the integral sign as well. So you will get here summation n is equals to 0 to infinity u n of x equal sine of x minus x plus x times integration from 0 to pi by 2 summation n is equals to 0 to infinity u n of t dt. Now let's expand this series. If we will expand this series, we'll get here u0 plus u1 plus u2 and up to so on equals to sine of x minus x plus x time integration from 0 to pi by 2. And here you will get u0 plus u1 plus u2 and up to so on dt. Now you can expand it this way, like sine of x minus x plus x time integration 0 to pi by 2 u0 dt plus x times integration from 0 to pi by 2 u1 dt and up to so on. Now let's compare both the sides. Take the first term with the first one. Take the second term equals to second term. Take the third term equals to third term and up to so on. So comparing both sides, we will get here u0 of x equal sine of x minus x. Now let's take u1 of x equal x integration from 0 to pi by 2 u0 of t dt. Now this is your u0 of x. So replace it here for t. That's integration from 0 to pi by 2. This is sine of t minus t dt. Now let's integrate it. After integration, we will get here u1 of x equal x and integration will give minus cosine of t minus t square by 2 and the limits of integration are from 0 to pi by 2. Now first of all apply the upper limit and then apply the lower limit. We'll get here x times 1 minus pi square by 8. Now let's find u2 of x. So it's x integration from 0 to pi by 2 u1 of t dt. Use this u1 of x for u1 of t here. You will get integration from 0 to pi by 2 1 minus pi square by there is x as well here, so this will be t dt. Now this is bracket is a constant, take it outside like this, and integration of t is t square by 2 0 to pi by 2. After simplification we will get here x pi square by 8 1 minus pi square by 8. Similarly you can find the u3 of x, that will be x pi square by 8 pi square by 8 minus pi 4 by 64, and then similarly you can find u4 of x, that is x pi square by 8 pi 4 by 64 minus pi 6 by 512. Now what whatever y values u values you found here, let's summarize it. Plug in here in equation number 1. We can write all these values as, we know that we took u of x as summation n is equals to 0 to infinity un of x. Let's expand it. U naught plus u1 plus u2 plus u3 and up to so on. Let's put the values, all of these values here. Sine of x minus x was u naught. u1 was this term. Let's put this value here. Plus x times 1 minus pi square over 8 plus u2 was this value, x pi square by 8, 1 minus pi square by 8 plus u3 was this value, x pi square by 8, pi square by 8 minus pi 4 by 64 plus u4 was this value, that is x pi square by 8, pi 4 by 64 minus pi 4 by 512. Now let's expand it, all these values. If we will expand all these values, we'll get here sine of x minus x. I'm taking up the x as common from all these values and keep these values inside like this. x1 minus pi square by 8 plus pi square by 8 minus pi square by 64 plus pi square by 64 minus pi 6 by 512 and up to so on. You can see that all the values are cancelling up. So you will get here sine of x minus x plus x. So you got the solution as sine of x. So sine of x is the exact solution of this given Fredholm integral equation of second kind.